Hi, my name is Mugilan and I'm going to present a slide about design a solution for material failure. Topic is material fracture in airlines industry. First, I will talk about introduction. Fatigue may be a common incident among all metal airframes. Because of the continual flight cycles and frequent use, the metal parts of planes become weakened over time and that they can eventually need attention and repair. This weakness is in cracks, which are visible small particles at first. Then with continued aircraft been fly, so it will show a bigger crack and we can seen by our eyes. An aircraft begins to age after its first flight, and aging becomes an issue when the aircraft can no longer be in maintenance. Next, we're going to talk about the discussion for this slide. The failure happens if metal is subjected either the multiple continual stress combined with stress relieving or stress in opposite directions. Example alternating compressions and tensions, continual bending in several directions and all. So in the slide I will show the example of material fracture in airlines and I show how to prevent the fatigue failure to understand the principle of fatigue failure on metal in airlines industry. Next, I will talk about the type of material was constructed in airplanes. First, using wood in the design of the first aircraft. So, wood is the one of material that has mechanical and physical properties that meet the factors needed for the manufacture of craft parts. This material possessed a high strength to weight ratio in laminate structures and is proof against adverse environmental conditions if it is the first subjected to particles preservation treatment. Next, the introduction of metal in airlines. So, the metal is designed in the aircraft manufacturing production industries include steel, aluminum, titanium and their alloys. Aluminum alloys are defined by having lower density values compared to steel alloys with good corrosion resistance properties. However, steel alloys have a larger enduringness, further as the next modulus of elasticity. As a result, steel is employed within the components of craft that strength is extremely important, like design the landing gears. Titanium is utilized in the designing of craft structures because it could be a lightweight, strong, and corrosion resistant metal. Next, I will talk about material failure in aircraft. Fatigue failures have occurred in several components of airline structures. These failures have concerned different materials and various conditions of loading and a surrounding. The failures typically begin at some local stress raises like a bolt hole, a fillet, a flange, a rivet, or a tool marks. So it will start over there. Cracks tend not only to start out a stress raiser, however, additionally to propagate through others. So this is the example of material fractures in airlines. So this picture is effluxions corrosion on the inner surface of the panel and door around a catch location. Next example is the picture shown a cross section through the panel showing the exfoliation corrosion. So this picture is a landing gear. So this manufactures to observe the loads arising from taxiing, takeoff and landing. Hard landing shock is a particle will be observed. Vibration is another will be categorized to be observed. Fatigue cracks can form in the struts and trunnions arms as the result of these loads. So now I want to talk about the how to prevent fatigue failure. One of the simple ways that to prevent aircraft fatigue failure is through regularly inspection. So we need to inspect all of the parts in the aircraft. So catching visually or otherwise detectable problems earlier will create the distinction between a maintenance, repair and failure. Next, the inspecting metal elements for inconsistency or damage without destroying the element. Moreover, this testing may include the use of ultrasound, X-ray scattering, X-ray absorption, electric eddy current, magnetic particles, liquid penetrants, and optics. So, ultrasound is a device, so it's a high voltage electrical pulse charged into the high frequency ultrasonic energy. When an ultrasonic wave hits the defect, it bounces back, which enable the inspector to see the depth or true size of flaws under the surface. So the eddy current. Eddy current is a coil sense an electromagnetic field through a metal surface, producing a loop pattern. So the defect will distort the pattern which captured and analyzed by a recording instrument. So the technician are then able to review the created pattern, seeing defect or any beneath the surface. So another method is to prevent fatigue is by keeping an aircraft surface polished. So when we polish, the surface can fan out the effect of fatigue better than those did not unpolish. So it also may buff out any existing surface damage on the area. So I like to talk about the conclusion of the last of this slide. Airplanes maintenance and repair processed a significant part of the assembly and introduction of recent materials and structures. Fatigue is the most common cause of structural failure in the aircraft. For this reason, service life of the components are described by flight hours and the components are substitute after certain periods. I mean like certain times, certain they will have a certain years or certain period to change the component in the aircraft by considering material fatigue limits. So from me, thank you very much.